Hello, I'm Bhavesh. Welcome to our channel. We make educational videos here, and this is our first series.
Hello class, let's take a little recap of what we've learned so far in this course. By now you should understand the basics of the binary system and have enough knowledge to be able to mimic any system, like the hexadecimal system or the Dewey Decimal System. You should also understand the core computer science terms, such as what is a byte, the ASCII system, and the RGB system. I also hope you have a fair understanding of the core concepts in computer science, like algorithms and data structures. Last week I hinted to y'all that fundamentally the only job a computer does is to perform calculations and to be able to store the results of these calculations. Now, what do I mean by that? The notion of storing results is an easy one to understand. There is a place in the computer called the memory unit where the computer stores most of its basic data. But when we talk about calculations, calculations may be a broad term, and in this context, it might mean two things. Originally, computer calculations contained the most primitive calculations only, such as addition, subtraction, division, and multiplication. The other type of calculations are what separates a modern computer from a computer which was created in the old days, such as a calculator. In a sense, a calculator can also be looked at as a computer. It's called a fixed program computer. In this computer, you can add, subtract, multiply, and divide, and you can only do just these things. You can only do primitive calculations. But in modern computers, you have something called human-written programs. So you can program and ask the computer to do anything you want. This idea was first created by Alan Turing. That's why you can access YouTube on your computer, but you can't access YouTube on your calculator, because the computer can read the code from YouTube to reach the website of YouTube and watch YouTube. So, at the heart of every computer, there are only 5 basic components. There is a memory unit, where the data is stored. There's something called the arithmetic logical unit, the ALU, which do primitive operations like addition, subtraction, multiplication, division. There's a control unit, which reads line-by-line code and maintains the flow of computers. And finally, there's an input and output unit that display and gain information. So if a program was running, there would be a set of instructions in the memory unit, which are parsed into the control unit, which reads the first line and asks the ALU to perform the operation. This ALU then takes the data from memory, the data that it needs to perform these calculations, and then stores the results of these data back into the memory. Now the control unit goes back and reads the next line of code and goes back to the ALU in order to process and do this line of code. This process continues till the code ends, and thus takes the output and finally displays it on the output unit. As you should know now, each language is different, not just by the things that they're used for, but as they're written as well. Like English, for example, it has A to Z alphabets, which are used as the primitive constructs. In the same way, the language Python has constructs of objects. Now there are 4 main types of primitive data objects in Python, such as integers, floats, strings, and boolean. Just like English as well, there's the syntax in language. In English, it's called grammar. For example, the statement cat, dog, boy is not valid because it's a statement which is noun, 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 which makes no sense. But the statement cat hugs boy is a valid statement because grammatically, noun, verb, noun is valid. In the same way, in Python, the statement hi, 5, true is not valid because object, object, object makes no sense. But the statement something like object, operator, object, where it's 5 times 7 is valid. As I mentioned earlier, there are 4 primitive data types in the Python language. The first is integer. Now integer refers to any number which is a whole number. such as 0, 1, 2, 3, 4, 5, 6, 7, till infinity, and till negative infinity. Float, on the other hand, refers to a number which has a decimal point in it. So 3.0, 3.2, 3.4, 3.6, they're all float numbers. This also goes from negative infinity to positive infinity. Boolean, on the other hand, is a two binary value. So it can only have true or false as its statements. And string is anything in quotation marks, such as hi, hello, or any statement that you might write in the English language or any language at all. In quotation marks, 3 is also a string because it's parsed in the way which is considered a symbol rather than the integer 3. In Python, most things are objects, so each and every object has the types, like the 4 I mentioned earlier. So what we can do is assign values to something called variables to create an object of any type you want. In most programming languages, you usually mention the type of the variable, like int or bool, but in Python you simply provide the name and use the equal to sign to assign the value of the variable. So if I were to create a variable pi, in this sense, I would write pi equals to 3.1415 and so on and so forth. So the variable pi is a float value, but I don't have to mention that while declaring the variable. So I can also write pi equals to true, and that would still be valid. But that doesn't make any sense if a person were to read it. The equal to sign basically says that anything on the right side of the equal to sign is supposed to be transferred into the left side of the equal to sign. So the right value is assigned to the name on the left side. Now that you can create any type of variable you want, you can manipulate these variables to do various things. These are some operators that you can use in order to compare two variables from each other. You can use the less than, greater than, less than equal to, greater than or equal to, and double equal to signs to represent equal to. Now, the operators you see on the screen are operators that result in true or false. For example, 3 less than 2, true or false. The computer would give you a value. 4 less than equal to 4, true or false. The computer would give you a value. And the variable pi equal to 3.14, the computer would give you the value of true or false, whether pi, the variable, has the value of 3.1415. There are other operators that you can use to create new variables, such as addition, subtraction, multiplication, modulus, and so on and so forth. Now that I've talked about how you can manipulate these variables, I want to talk about how you can use input and output to take input from the user and print out output to the user and contact with the user what you were trying to say. So you can use something like input to take values. This works a little something like this. So if I were to write input, and I can write anything in the place here. So I can write hello, what is your name? And now the computer would ask me what my name is, and I can write anything like Bhavesh. So it would print out Bhavesh. You can also save these information, so you can do something like name equals input hello name. So now I've stored a variable which has my name. And now if I output using the print statement, I can do something like print, and here I put the value. So if I were to put name, I would get hello Bhavesh. I can also concatenate things to say something like print hello, and I can use the comma The comma means to separate values with a space. So if I were to write hello, comma, name, then it would give me Bhavesh, hello Bhavesh, with a space in between. But if I were to write print hello plus name, I would get hello Bhavesh with no space in between. I hope that makes sense. And that's it for our first class.
If you like the content in this video, please like and subscribe for more content on this topic.